In this video, we'll be exploring creating objects. So up to this point, we've been looking at primitive values, ints and such like. However, we've also looked at the string class, and the string, as we saw, was an object. So the variables that we create can either hold a primitive value or they can hold what's called a reference to an object. Because we can use the class name as a type to declare an object, reference to use as a variable, as indicated in string title, this is what we call a object reference. Now, at this point, when we've written string title semicolon, there is no object being created with this declaration. Okay, so all we've done is set aside some space in memory to hold a particular string variable. Now, this reference holds the address of an object. Okay, so all we've done is set up an area in memory. We've called it title, and it's a reference to hold a string object. The object itself we have to create separately. So, generally, let's say 99% of the time, we will use the new operator to create an object. Using the new operator is called instantiation. And the reason it's called instantiation is because when we create an object, it is an instance of a particular class. So instance of the class, and we extend that to instantiation. So in the line below, we have title, which we created in the previous slide. Let's just go back. String title. Okay, so now we are assigning a value exactly the same way we assigned a value to a primitive. So title equals new string, and in this string we are giving the string in quotes, as we know, Java Software Solutions. Now let's have a look at that in a little bit more detail. That part where we have created, or where we have written string and then in brackets the string, this is called the string constructor, and we will be looking at constructors in more detail as we move through the topic. It's a special method that sets up an object. Now, we have seen in other instances where we have, once we've got an object, we can use the dot operator, the little dot, to invoke methods, as we have seen with system.out.println. The dot is the dot operator, and the println is a method of the system.out object. So exactly the same way we can use this with any other object that we've created and invoke the methods that belong to that class. So here we have numchars, which would have been created as an integer or an int type variable, and we are going to get title, the string we created in the previous slide, and a method of the string class called length. Now these methods, in this case, it does return a value, and we can assign it to the value on the left-hand side. In this case, we are getting the length of the string, which is held in title, and we are assigning it to the int variable numchars. So really what we're doing is we're saying, okay, I have this object, do this service for me, and in this case, tell me how long you are, and then once I know that, I'm going to store you in another variable so that I can use you later in my program. Now, the difference between primitives and objects when we are talking about variables, there are some subtle differences. A primitive variable contains the value itself. However, an object just contains the address of where the object lives, an object variable. So when we create an int variable, that variable actually contains the value. and we'll see how this works in a minute. When we create an object variable, it contains the address of where that object is stored in memory. So really it's just a pointer to where we can go and find this object. So rather than we dealing with arbitrary addresses and things like that, we often depict this reference graphically, and this is what it looks like. With our primitive num1, it's an int variable, it actually holds the value. Name1, which is a string variable, an object reference, actually has a pointer to where that string is living. Now, for all intents and purposes, for our topic here, the distinction is important, but it's not really critical. There are a few little critical things that we have to look at, and we'll have a look at that in the next slide. So, when we assign a value to a variable, it takes a copy of the value and it stores it there. So for primitive types, ints, doubles, floats, those sorts of things, if we declare two variables, one called num1 and one called num2 of type int, and we store 38 and 96 respectively in those variables, that's the sort of picture we've got. Then what we're going to do is we're going to say num2 is assigned the value of num1. Now, after we've done that, this is what it looks like. Both num1 and num2 have the value 38, but they are totally separate entities. Okay? So we start with num1 and num2, 38 and 96. We do an assignment where we assign num1 to num2, the value of num2 into num2, and then both of those, even though they're individual variables, have the value 38. And we can reference those in our program as num1, num2, and if we change num2 later, it will not affect num1. Now, for reference assignment for objects, it actually copies the addresses. So before, in the same instance we had before, we have name1, name2. Name1 points to Steve Jobs, name2 points to Steve Wozniak. Then we do the name2 is assigned name1, and unlike the primitives, we get this situation where name1 and name2 both point to the same place in memory. Okay, so there's the difference. In the previous slide where we had num1 and num2 both holding the same value but distinctly separate variables, here we have name1 and name2 both pointing to the same place in memory. And this is what's called an alias, because if we change the value of one, it will automatically change the value of the other one. Okay, so we can then access the same piece of information via two different variables. Okay, can be useful, but if you're going to do it, make sure you understand why you're doing it and manage it very carefully. Okay, so if you change it in one of these aliases, all of the other aliases change, because really there's only one object that they're all pointing to. So we're running our program, we've created all these objects and this thing's happening, and then all of a sudden we don't have any valid references to an object left in my program. So therefore we can't access it, it's useless, and in Java parlance it's called garbage. And in most places it's called garbage. Now, fortunately for us, Java performs automatic garbage collection on a periodic basis. You can force it to do it. There are some methods for you to be able to do that, but typically you will just let Java do it itself. And what it does is it just collects this garbage, and it makes, or it enables the program to retrieve the memory where that object was stored, and therefore we get it back and we can use it in future. In other languages such as C and C++, you, the programmer, is responsible for performing garbage collection. Okay, so just interesting information, and if you really want to have a look at how to do the garbage collection yourself, by all means have a look in the API, and we'll be having a look at how to access the API in a future video. Okay.